screen. Well, good morning, AFAME family. Welcome to our webinar, one of many that we've been holding and have been having a very successful turnout with our webinars. So thank you for joining us today. Today's webinar is on how to make your building safer in the era of COVID-19, especially as it relates to air filtration. And so before we get started, I will go through a couple of housekeeping tips just to give you an idea how our webinar runs. As a reminder, today's webinar is being recorded to share later. And yes, all participants should be muted when they come in, so you do not have to worry about not being muted. Only the presenters will be shown on the screen with supporting presentations. So you're really just going to see Jim and the presentation this morning. The attendees will be allowed to post questions in the chat box. So you'll see a chat box at the bottom of your screen there, or at the top, depending on where you have your controls. And you will be able to post any questions during the presentation that relates to what Jim might be presenting. And we can stop and answer those questions as they come through, or we may save them till the end, depending on the question and the timing. But we're very welcoming of questions in the chat feature. That's what being live on the webinars means. You actually get to ask some questions that you may not be able to ask when you watch the recorded version later. And we expect today's presentation to last no more than an hour. Before I introduce the speaker, I do want to say thank you to Tex-Air Filters. We have Christine Kelly here with us this morning. Most of our local members are familiar with Christine. How are you this morning, Christine?
Pretty good. Hope everyone's doing well too. And I know we've been getting a lot of questions about air filtration right now. And so I hope this presentation that Jim's about to do answers a lot of questions and gets everybody thinking about, what the next steps are going forward.
Excellent. Well, we always appreciate Tex-Air Filter. They have been a long time member of AFAME and sponsor. I think Patrick has been around AFAME. Patrick Rosenthal has been around AFAME for many years. I mean, his kids, he's been here since before his kids were born, and now they're getting grown. So without further ado, let me introduce today's speaker, Jim Rosenthal. He is the co-founder of Air Relief Technologies, the parent company of Tex-Air Filters. And he's been in the air filtration industry since 1997 and is a certified air filter specialist, CAFS, and he's from the National Air Filtration Association. That's where that designation is from. And he apparently has served as a president back in 2010 as well, so he's very familiar with association business. He contributes to professional publications on filtration, indoor air quality, environmental controls, allergy and asthma type incidents issues. He received his BA from Colorado College. That's awesome. And his master's from the University of Pittsburgh. He also attended the Netherlands School of Business. Wow, you get around. You got a lot of education, which is why you're so good at what you do. And a very interesting fact is he's the president of the Fort Worth Civil War Round Table and participates in a number of other national local organizations. So that's really cool. So without further ado, Jim, I'm going to let you take over, and Christine and I are going to pop out and let you do your presentation.
Great. Well, thank you, Amy. Appreciate that very much. You're always great to work with. I think I did a presentation for AFAME, might have been 8 or 10 years ago. I think it was in a seminar room, and really enjoyed the group. And I'm glad that our people at Tex-Air Filters are involved with AFAME. It's a really excellent organization. So what we're going to talk about today is how to make your building safer in the era of COVID-19. So COVID-19, or SARS-CoV-2, as the official name is, what exactly is it? What's a virus? And what does that mean? Well, a virus is, it is really not a living thing in and of itself. It has to live on something else. So it's basically a parasite. And it will take over the RNA of its host. And that's where all of the issues come in. The virus itself is about 1.25 microns. And I hope everybody knows what a micron is, but just in case, a micron is 1/25,400th of an inch, or 1/1,000,000th of a meter. But remember, the virus does not live on its own. So right now, it looks like the smallest the particle size the virus is going to be in is about 1 micron. It's primarily a respiratory virus, but it does attack other organs. They're finding that there's some brain damage. There's some issues that people are having mini strokes in their cardiovascular system. But primarily it's a respiratory virus that attacks the lungs and the rest of the respiratory system. So it can be transmitted by fomites, droplets, or aerosols. Fomites are basically things that are found on surfaces, usually created by somebody coughing, sneezing. The particles go to the surface, or by touching. If you've ever seen the videos of people holding a glass and then passing the glass around in the room with the phosphorescent light, it's amazing how much can be transferred through touch. Droplets are generally airborne, but fall about 3 feet, maybe 6 feet away from the source. And aerosols are smaller particles characterized by being able to be airborne for extensive periods of time. A 1 micron size particle can stay in the air for anywhere from 3 to 6 hours. So it can be emitted by the carrier and spread and stays in the air for an extended period of time. So it's not as contagious as the measles, but it's more contagious than the flu. The big problem with COVID-19 is it has such serious conditions that it creates. It doesn't like alcohol. That doesn't mean that you can go out and have an extra beer and think you're not going to be exposed to COVID-19. We're talking about alcohol as in solutions to clean your hands or clean surfaces. Doesn't like sunlight or soap. It's interesting. They've found that you can actually clean a mask by leaving it outside in the sun for a day, and all of the virus is dead. So the first thing you do, and now we're talking about how can you make your building safer. The first thing you want to think about is ventilation. If there's somebody who's a carrier or a spreader inside a building, what we want to do is be able to dilute whatever they emit, any of the virus that comes out. We want to dilute it to the point where it will not be able to be contagious for other people. So we want to maximize ventilation in buildings. Maximize ventilation. Most obvious way to do that is to open windows. Now, many of you are thinking, we don't have any windows in our buildings. How are we supposed to open windows? If you have windows, open them. Try to get as much outside air as possible. And I also understand that it's 100 degrees outside. Opening windows may not be very popular with your with the people who are in your buildings. But you can run your HVAC systems with as much outside air as possible. Virtually every commercial building of any size has fresh air intake, usually about 20% of the air going through the system. You need to make sure that those that is maintained, and if possible, increased. Now, some of you may smile when you read this, but I've been doing this for a long time, and it's surprising to me how many engineers decide that they're going to save money for the building by closing the fresh air dampers. Please do not do that, and do not allow the building to not have fresh air that it needs. So don't close fresh air dampers. Now, many buildings have what's called demand controlled ventilation. This is where there are sensors in the building that sense the level of carbon dioxide, CO2. And the ventilation system will be activated when the CO2 level reaches a certain height. Well, it's important to understand that those systems should be deactivated now. You want as much fresh air in the building as you can stand. And I say stand because obviously if you allow so much fresh air in the building that it gets to be 90 degrees, you're not going to have very happy people in the building, and that's not going to be very helpful either. So it's got to be a balance. You want ventilation, as much fresh air as possible, but you need to make sure that your people are not so uncomfortable they can't do their work in the building. Here's a little tip. You need to keep all ventilation fans running in restrooms or anywhere else you might have a ventilation fan. You want to encourage the fresh air intake. And the way you do that, if your ventilation fans in your restrooms are properly ducted, they're going to be dropping the air outside the building. And the more air that goes outside the building, you create negative pressure, bringing air in from the outside. So anything you can do to vent air to the outside is going to be beneficial for ventilation in your building. Let's talk about filtration. What exactly can we do with filters? So ASHRAE, the American Society of Heating, Refrigeration, and Air Conditioning Engineers, has a special committee that is dedicated to handling these contagious outbreaks. March 27th of this year, they recommended final filters of MERV 13 or higher. And MERV is the minimum efficiency reporting value. It's a way to distinguish the efficiency of a filter. MERV 13 is high. It's going to remove a very high percentage of the particles that can transmit COVID-19. But they also realize that most buildings, or many buildings, especially if they have any age on them, are not going to be able to run their AC systems with a MERV 13 filter or above. So they put in there a provision that you can also do it at the best achievable without diminishing the airflow. And the Centers for Disease Control, the CDC, came out in May of this year. They recommend the same thing, MERV 13 or the highest compatible with the filter rack. So what does that do to the filter market? You might have heard about this, but in our business, this is probably the most stressful time that people have had in the filter business since I've been in it. And here's the problem. Before the pandemic, MERV 13 and above filter usage was about 5% of the market. It's MERV 13, MERV 14, MERV 15, and MERV 16, 5% of the market. So we have ASHRAE and CDC and other experts saying you need to use MERV 13 and above. And here's the problem. The demand is up 3 to 10 times over 2019. So it is very difficult to get a MERV 13 filter or above at this point. And if you try to go out and buy filters, you realize that there's usually a lag time, a delay, because of just the market was not prepared for it, did not know that this was coming. I talked to people when this first came out in the industry, and they told me they could increase production by 30% by just increasing the production off existing machinery. But to really deal with this type of an increase, it was going to take about 6 months. So that was back in March or April, I guess it was April. And here we are. So we're looking at later in the fall and maybe even the winter before we can have enough MERV 13 media on the market. And here's another problem. I'm sure you've all heard about the shortages of N95 masks. It just so happens that N95 masks are made from the same material. It's a melt-blown media made from the same material as MERV 14 filters and above. So most of the melt-blown for MERV 14 is going to masks. It is not going to the filter market. Melt-blown media right now is basically a mask media. And a number of manufacturers have told us that they will not be manufacturing any MERV 14 filters using melt-blown media until after the first of the year. So that's the good news. Bad news, we think we can do a lot through filtration. We have some limitations in terms of the supply, and everybody needs to be aware of that. But what do you do as a building person, manager or building engineer? How do you make sure that you get the best filtration? First of all, you need to make sure your systems, your HVAC systems can handle the additional pressure drop of MERV 13 and above filters. They are more resistant. They do require greater airflow. And a lot of systems are marginal with a MERV 8 or a MERV 10 filter, and going up to a MERV 13 really is going to tax that equipment and maybe make it so there's not enough airflow and the system will not operate correctly. So that's the first thing you need to do. Can your systems handle the more efficient filter? If not, and then you need to consider upgrading the necessary components of the system. Now, we're not engineers. We can't tell you what you need to do, but it could be that a relatively inexpensive upgrade of the fans could make it so that the system can handle the more efficient filters. But whatever it is, you need to look at it, evaluate the cost, and see whether or not that can be done to handle the MERV 13 filters or above. Or you can consider going to deeper filters. You can go to maybe a 2-inch or a 4-inch. It might mean a modification of your filter racks, but here's the advantage. With filtration, the way that the pressure drop is determined of a filter is not the face area of the filter. Let's say you have a 24 by 24 face area of a filter. The way you determine it is not the face area, it's the media area. So that's why you have pleats and filters. They give you the same face area, but substantially more media area. That means the velocity pressure coming through your duct is going to be distributed over a wider area, and therefore you have less resistance and a lower pressure drop. That's what you want. So you can go to higher efficiency filters using the same fan, the same equipment, if you can increase the thickness of the filters from a 1-inch to a 2-inch, or maybe a 2-inch to a 4-inch. That might give you enough room to make sure that you have enough airflow. So what do you do? I mean, what are the alternatives? Excuse me. Well, one of the alternatives is to make sure that you go to the best achievable. If you can't go to MERV 13, your equipment won't do MERV 13. You want to go to the best achievable with what you have, and that might mean a MERV 12, or a MERV 11, or even a MERV 10. The idea is to get better efficiency. Now, the way I look at all this stuff, everything that we're doing, all the safety measures, the masks and the social distancing and everything, and the filtration and ventilation, everything is based on the odds, as I say. And I'm writing an article right now, and I start off by saying that the odds of winning the Texas lottery are 1 in 25,200,202. And my odds of winning the Texas lottery are actually 0 in 25,200,202 because I've never bought a ticket. But the average person is 1 in 25,200,202. What you want is to get to as close to that as possible. If the odds are 1 in 10, that's a bad deal. What you want is the lowest odds possible. So in your buildings, if you're doing things like social distancing, mask requirements, supplying hand sanitizer, washing down surfaces, all those logical things, you're going to improve the odds for you and everybody else working in your buildings. And that's what we're trying to do here. Try to get the best filtration that you can for your building. It may not be MERV 13, but if you do the best you can, you're bettering the odds, and that's what you really want to do. Okay, so when you're changing filters, if you are doing it, if your engineering crew is doing it, you need to make sure that everybody wears protective gloves and masks. Now, there's never been anything identified in a filter at this point of a live virus COVID-19. However, in the past, there have been some tests that were done, actually at the University of Texas, showing that there was RNA, which is the marker. That doesn't mean it's live, but there was RNA of other viruses that were found on filters. So we strongly recommend that everybody changing filters, turn off the system. You have to have the system off. Turn off the system and then wear protective gloves and masks. All those things are important. And then we recommend that you bag all used filters and dispose of them immediately. Put them in plastic bags, seal the bags, and dispose of it. You can do it, certainly do it in a dumpster, but you need to make sure that you don't carry filters, dirty filters, through the space of your building. Very, very important. So what are some additional steps that you can take? Well, one of them is ultraviolet lights. The ultraviolet lights, if properly installed, and if they are robust enough, will neutralize any virus in the airstream. Now, if you think about these systems that go in houses, little 12-inch ultraviolet bulb in an airstream with the air going by at 300 feet a minute, the chances of that device actually deactivating COVID-19 is very, very low. You might give the virus a suntan as it's going by, but it's not going to really do anything. So in the systems that you look at from a commercial point of view, the systems need to be robust enough, and they need to have three things. And you can figure these things out with a mathematical equation, which I don't have here, but what you need is the intensity of the bulb or bulbs. You need proximity to the virus, and you need dwell time. Now, sometimes that means it's a longer chamber where the UV bulbs are. They're put in lengthwise. They might be 4 to 6 feet long. Sometimes it means you have mirrors in there to increase the intensity. But all those things are necessary. And by the way, that is why UV lights work so well when they're pointed to a coil. They've got intensity, proximity, and dwell time. All those things are important. So if you're considering putting UV lights in your buildings, keep those things in mind, get a good company to work with, and make sure that the system is robust enough to do the job. Now, you're not going to be able to distribute the air through the filters enough in some areas of your buildings. It's important to have other ways that you can make sure that you clean the air. And many people are going to HEPA air purifiers for supplemental air cleaning. Now, HEPA refers to high efficiency particulate air. It's a special type of filter that pulls out, the definition is it pulls out 99.97% of the particles at 0.3 microns. Many people don't know what that really means because they don't understand how filters work. But it's kind of counterintuitive, but filters are actually more efficient at below 0.3 microns and more efficient at above 0.3 microns because of the various mechanisms that make filters work. There's a thing called diffusion. Diffusion works really well on small, very small particles. Another thing is called interception, works well on some small particles, and it also works well on medium-sized particles. Well, as those two things intersect, there is a low point, and that low point is called the maximum MPP, minimum, I can't remember, MPPR, minimum penetration point. So where that is at 0.3 microns. People, I've read articles where somebody says, oh, the coronavirus is 0.12 microns. It's not going to be captured by a HEPA filter. That's ridiculous. The HEPA filter is going to capture, even at that point, it's going to capture 99.97% of the particles. So HEPA air purifiers are a great way to supplement, and they're a good idea to put in buildings. So what about the other options? I'm sure you've heard about all these things: ionization, polarization, oxidation, neutralization, monetization. There are lots of really good sounding systems that are being recommended for indoor air quality at this point. By the way, these are not new. These things have been around for years. And basically, I have been opposed to them for years. And the reason is really simple. None of these systems that I know of have had good peer-reviewed studies done on them to either show the efficacy or the safety of these types of devices. Now, I have a saying: if it sounds too good to be true, it isn't true. So from your perspective, I would highly recommend that you stay with proven technologies, things like ventilation and air filtration. If you're going to do any air purifiers in your building, do HEPA air purifiers only. And then UV light is another proven technology. Going beyond that, I would be very skeptical, again, unless I had good peer-reviewed studies showing the safety and the efficacy of both. Okay, so that's kind of the summary of what you need to be doing from your building perspective. Let's talk about something else. There are a lot of things that we're doing to try to protect ourselves. One of them is masking, which is actually very effective, not only for the person wearing the mask, but also from the people in the area around the person wearing the mask. You wear the mask half for yourself and half to protect other people. Now, there's also a thing called a face shield. This is a plastic device that goes over the front of your face. It's become very popular as well. And there's some advantages to it. You can't touch your face. You can see somebody talking, see their lips moving inside the face shield. It's comfortable. You don't have anything over your mouth. Some people think it's easier to breathe, but here is a fact. It should not be worn. A face shield should not be worn without a mask. And I'm going to prove it to you. And you can do this yourself. Take a shield like we have here. And there's a fan blowing. It's blowing at 3.1 miles an hour, which is about the speed of somebody walking. And you can do the tissue test. And the tissue test is basically taking a piece of tissue. It can either be facial tissue or toilet tissue, and put it in the airstream. And then move it over behind the mask and watch what happens. What happens is the air goes around the mask and literally is drawn inside the mask. You see where that tissue is? It's right in the breathing zone of the person wearing the mask. And this is not a trick. This is physics. It's what happens is the positive pressure on the outside of the mask creates negative pressure inside the mask. causes what's called turbulence and draws the air from the sides of the mask, the bottom of the mask, and the top of the mask directly into the breathing zone, excuse me, the shield, directly into the breathing zone of the person wearing the shield. So it's not going to work as advertised. I've seen teachers, pictures of teachers wearing a face shield only. Drives me crazy. I'm sure you'll go, I went into Costco yesterday, saw 3 people, older people wearing face shield only. They're walking around. If somebody has the coronavirus, they walk through the area where that person was. It's almost like a supercharger drawing those particles into the breathing zone of the person wearing the face shield. And by the way, the same type of thing can happen if you have what are called desk shields. That if there is an airflow going over the top of the desk shield from a supply air vent or from wind coming from outside or a fan or anything of that nature, exactly the same thing can happen. If you have people using desk shields in your facility, do the tissue test. Walk up to that shield, put the tissue up. If it's going toward the shield, that means that the air in the surrounding area is actually being drawn to the area that we're trying to protect the person. So desk shields may be a problem also. I know for sure face shields are, the physics are the same with a desk shield. If you have airflow going over the top of it, around the side of it, you need to be very careful and test it. Okay, a few weeks ago, on August 6th, I got a call from a reporter, from Wired magazine. They're both hard copy, but their biggest exposure is on the internet. And he said, I understand that you know something about air filters. And I said, yeah, I know a little bit about air filters. And he said, what do you think about this device of sticking an air filter on a box fan? And this idea has been around for quite a while. I mean, I remember reading about this 10 years ago. And I said, it works. It actually is very effective. And then he said, well, how effective is it? And I said, I don't know, but I can go out and buy a box fan and I'll stick some filters on it and I'll let you know. So he writes this article, and it's, could a janky jury-rigged air purifier help fight COVID-19? Indoor air experts think, sure, maybe, but why the hell not? We convinced the CEO of an air filter company to give it a try. Well, that CEO was me. So how did it do? And by the way, that's a 4-inch filter on there. Why did we do a 4-inch filter? It's just like we talked about earlier. We did a 4-inch filter because it has lower pressure drop. So how did it do? How does our box fan with a MERV 13 filter air cleaner perform? We've got particle counters, and it actually does pretty well. If you look at 0.3 microns, there are 1,596,900 in the room. We tried to take a room that was fairly dirty. But after we removed 427,000 of those, we removed about 26%. Now remember, the below 1 micron size particle are very difficult to pick up. Where you're really interested in knowing how it works is at the 1 micron. UM stands for micron, by the way, one UM size. There are 47,900 in the room. We dropped it down to 28,600 and reduced it by 59%. 5 microns, we reduced it by 86%. So that's your target particle size, 1 to 5 microns. It's actually very effective. And you can put a box fan virtually anywhere, put a good filter on it, and decrease the particle count. Now, does that mean you're not going to get COVID-19? I don't know, but I absolutely know it removes the particles from the air. It's going to better your odds, and that's really what you're looking for. You want to improve your odds. So what's the flow rate? No filter, 24 inches away from the fan was 780 feet a minute. With a 1-inch filter, MERV 13 filter is 320 feet per minute. With a 2-inch, it was 400 feet per minute. And with a 4-inch, it was 460 feet per minute. Now, I've had a question like, what is that going to do to the life of the fan? Well, interestingly, if you decrease the flow, you actually decrease the horsepower of a fan, use a little bit less energy, believe it or not, and it's probably going to be just fine. Now, I'm running the MERV 13 with a box fan air cleaners in our facility at medium, but they do a tremendous job. If you think about that, 4-inch filter, 460 feet per minute, the opening is 20 inches by 20 inches. It creates a tremendous amount of clean air. So those are the comments that I would have. This is not an easy time for anybody. I would certainly recommend working with everybody in the building to try to make it as safe as possible for the occupants. Part of that is the occupants themselves. They need to help, but also part of it is every person on the management and engineering team working as well. They need to set good examples. Everybody should be wearing masks. Everybody needs to keep the proper safe distances. Your jobs are to make it as safe and feel as safe for the people in your buildings as possible. And it can be done. It's not going to end tomorrow. We're doing a great job of starting to reduce the transmission of the disease. We just have to keep it up. Thank you very much.
Thank you, Jim. Very good. Very interesting. I learned a lot yesterday while we were doing this, and I think you answered some of the questions that I had heard kind of bubbling around. And there are a couple of questions in the chat that I'm going to read to you because I'm not sure that you'll be able to see them. And I'm sorry, they were coming through as you were presenting, but I just did not feel right about interrupting you because you were on a flow. No pun intended on the flow part. No pun intended.
Okay.
One question from Ron Tuttle is 40% outside air enough?
40% outside air?
Is it enough?
Yeah. You know, the ASHRAE recommendations were calling for 100% outside air. We've been doing this for a long time. I've seen very few buildings that can have 100% outside air. The average is about 20% outside air. I would say 40% outside air is wonderful. It's you know, how much is enough? You know, nobody knows exactly the answer to that, but it dramatically improves ventilation, and I would say it's a very good step to be able to do 40% outside air.
Excellent. I agree with that. I've always heard that they say the minimum percentage is 15%. Has that changed recently, or is there an industry standard like the minimum you should go ever? I know, don't close it off. And I know it all has to do with some CO2 levels and things like that, which that's kind of going out the door a little bit now too. Right,
and there are some ASHRAE guidelines that tell you the amount of fresh air per person and per cubic foot, and those are important. But my experience is most buildings are at 20%. We need to try to increase that if we can. And I know it costs money. I mean, there's no question. When it's so hot outside, you're bringing in air that hasn't been conditioned and mixing that with air that has, but it needs to be done. Some of the researchers are saying that CO2 is a pretty good measure of whether or not the room is ventilated properly or not. And if you don't have CO2 gauges, you probably need to get them. I think that'd be a pretty good guide. Whether if the CO2 is building up, it definitely means you don't have enough ventilation. So I think that's a good point. By the way, give you a little example on why it is a good idea to not be in small rooms. The most dangerous place in most of your buildings is going to be either the bathroom or the elevator, the small or very small conference room. We have a small conference room in our building. Just outside my office. I have a little spray bottle and I spray do a bunch of tests. I'm a particle counting nerd. So I did a test, closed the doors, put a spray into the air. The 1 and 5 micron size particles in that room dropped in the first couple minutes, just because they were starting to spread out. But at 10 minutes later, they were still considerably higher than they were when I started the test. There was no ventilation and nowhere for those particles to go. I look at it, it's kind of like you're in a small room, or let's say a small pool, and you throw a rock in. Well, the waves will go out from that where that rock entered, and then if there are walls that are close, they're going to hit the walls and start coming back in again. So what happens is that dispersion of the particles never happens in a small room. It bounces off the walls and literally starts coming back again. So you have somebody that sneezes twice and you got a huge particle count, it's going to stay in there. And that's the thing. You don't want to be in a room where 30, 40 minutes with somebody that has COVID in a poorly ventilated space. There's a pretty good chance you're going to walk out and you're going to have it. Okay.
Great, good answer. Next question, what are your thoughts on RGF lights, and can you tell me what RGF lights means? That's Amy asking what RGF means.
That kind of gets into the ionization stuff. I'm familiar with the device. I am not a fan. I've seen their tests, and the tests that I've seen are done in very small chambers and do not reflect what happens in actual building environments. I would not buy it myself, but that's my personal opinion. And I don't think that it really gives people the benefit that they should have for the money spent.
Another good answer.
I can go on, but anyway.
Well, and I'm sure you put your contact info in this PowerPoint that we will definitely share with everybody afterwards in case they want to have some one-on-one questions with you.
Sure.
The next question is, what do you think about the gator mask, the fishing mask?
Oh, that's interesting. So the study came out and it said, oh, the gator mask actually has a negative. It doesn't really help at all. It actually creates more small particles. And then the scientists have got on that, who've actually been doing a lot of research on mask materials. And the general consensus of these scientists is that was wrong. That finding was not correct. In fact, one of the real experts is Dr. Lindsay Marr at Virginia Tech, and if you want to follow somebody on Twitter, follow her. She's just really great on this stuff. She's done testing on it and found that the gator mask was actually quite effective, and 2 layers was one of the most effective types of homemade masks.
Very good. Next question. How often should the filter on the box fan be changed?
Well, if you had somebody in your building that had COVID, obviously it'd be changed immediately. And same things, you have to be careful about changing it. But if you have a 4-inch filter on there, you got great airflow. If you run it, I would probably start running it an hour before most of the people came into the building and an hour after. I probably would not run it overnight because basically they're not going to be any particles to pick up. But I would think it'd probably last a month or more.
Okay, next question is, how likely is that COVID would enter your system with a 16-foot high supply return in a 45,000 square foot open office environment? 16-foot high supply returns in a 45,000 square foot open office environment.
It kind of goes back to that example I gave you about a small room. The larger the space, the less likely that is going to infect a number of people. Again, think about how a virus moves. Some of it moves in a cloud, like smoke moves, but a lot of it moves in direct relationship to the distance from the source. It's kind of like that throwing the rock into the pool. It's moving out. So if you have a 16-foot ceiling, 45,000 square feet, chances of getting anything are very, very small. And that's, you know, and that's fairly safe. I've done tests with a room that's 20 by 25 feet, 8-foot ceilings. Within 2 minutes, 3 minutes, you basically don't detect any appreciable increase in 1 or 5 micron size particles. So it's going to be diluted pretty effectively. That's a big room.
It is a big room.
And I always feel, I go to meetings, most of them I go to, we have masks. There's one that I go to, it's in a ballroom, probably about the same size. We're about 10 feet apart from each other. And I feel pretty safe. I think my odds are pretty good that I'm safe. So if you have the proper distancing, it's a fairly safe environment.
Next question. What is your suggested minimum CO2 level?
I don't really know enough about CO2 to give you a number. So I'm going to pass on that one. I probably would be wrong.
You know what? The best speaker in the world is when they say, I pass on something instead of giving them an answer. Best speaker in the world. And then Joseph is asking, and I'm not sure this is directed at you so much, maybe something AFAME should work on, but he's asking about a list of local vendors who design, install UV systems properly. I'm going to add the word properly, because UV systems are only as good as they're installed in the right size and all that.
Yeah, and I think that the properly is the right thing. I mean, there are definitely some good manufacturers that have representation in Austin, and for a little plug, I guess, you know, we would certainly be somebody that you could talk to. But I mean, there are a number of good companies, and this is not a fly-by-night industry anymore. This is a very sophisticated, excellent industry that really can help. So you go to any of those 3 or 4 companies, and you're going to get a good product.
Good. And Joseph, you might look at our vendor search on our website to see if anything pops out there. I think that's all of our questions right now. We had quite a few more questions than we normally get. If there's no more questions, I'm just going to, oh wait, good one. Okay. Bob Wilbert has a question for you.
Okay.
Thanks, Bob, for participating in our webinars. It's good to see your name on all of our webinars. Just a quick shout out to Bob there. Is it difficult to get the correct size filter for the box fans at this moment?
Probably not. You're just looking at one filter. So they're you know, Home Depot has MERV 13 filters. If you want thicker, you need to go to a filter company like Tex-Air filters, but it's not difficult. It's a standard size. 20 by 20 is one of the key sizes in the air filter business. So it shouldn't be difficult at all.
Good. All right, well, I'm going to go ahead and wrap this up at about 10 minutes till 12. This has been an excellent presentation. I'm very pleased with the turnout. Our webinars are being successful. We're glad to keep continuing to educate our members during this time. This was a very important topic. I feel good about it. Thank you, Jim Rosenthal and Texas Air Filters, and Christine Kelly and Patrick Rosenthal for the support. And we got some thank yous coming through on the chat. So everybody say thank you to Jim. Even if we can't hear you, say thank you, Jim. Great job. Again, we did record this webinar, and we will share that. I usually post them on the website, so you can always look at the website to see our recorded webinars, current and past. And everybody have a safe COVID world out there. Have a great day.
Thanks, Amy.
Thank you.